So today, we're going to dive into the story of just one element. But it's an element that fuels our fires, powers our bodies, and literally paints our planet blue. This is the incredible, dramatic story of oxygen, and how its arrival turned Earth from a strange, alien world into the home we all know and love today. You know, when you look out into our solar system, what do you see? You see dusty red worlds, you see giant gas planets, but then there's Earth, an explosion of life. If some intergalactic explorers were to swing by and scan our solar system, the life teeming here would be impossible to miss. So what is it? What makes our planet just so different?
Well, the thing is, if you could go back in time, you wouldn't even recognize Earth. It was basically an alien planet. The atmosphere? Totally unbreathable. The oceans were this murky, weird green color from all the dissolved iron. And life? Well, life was just simple, microscopic stuff. The key difference between that world and our world? Oxygen.
O for awesome!
And how we got from there to here, that's one of the greatest detective stories in all of science.
So, to crack this case, we have to travel way, way back in time. Back to an Earth without oxygen, a planet without breath.
Okay, and this is where the story gets kind of weird. We think of oxygen as the gas of life, right? We need it to live. But for the very first life forms on our planet, it was a deadly poison. All of that early life was anaerobic, which just means it didn't need oxygen to survive. In fact, life actually figured out how to thrive long before oxygen ever showed up.
So where was this early life actually hanging out? What did that even look like? Well, picture this. Some microbes were clustered around these searing hot deep-sea vents, just feeding on a soup of chemicals bubbling up from inside the planet. Others had figured out how to use sunlight, but in a way that didn't make any oxygen. And then you had these things called methanogens, microbes that literally made a living by producing methane gas. Life was finding all these creative ways to get by.
And then, everything changed. A new player entered the scene. A tiny microbe that was about to unleash a technology so powerful it would terraform the entire planet, and it did it completely by accident. This was the beginning of the oxygen revolution.
And here it is. Meet our prime suspect, Cyanobacteria. These little microscopic organisms invented a brand new way to make a living, a process we now call oxygenic photosynthesis. It's a perfect example of how one tiny biological breakthrough can have massive, planet-wide consequences.
And what they did was, honestly, pretty straightforward.
Hi there! Welcome to the lab!
Step 1, soak up some sunlight. Step 2, use that energy to crack open water molecules, which were, everywhere. And step 3, release what was left over, which happened to be oxygen gas. To the cyanobacteria, oxygen was just trash, a useless byproduct they needed to get rid of.
And that's really the punchline to this whole thing. One microbe's garbage became the treasure that would reshape our planet's chemistry, its geology, its biology, everything, forever. Think about that. The most important change in the history of our world started out as industrial pollution.
But this change? Oh, it was anything but gentle. The rise of oxygen was a global catastrophe. And at the same time, an unbelievable opportunity. It was a poison for the life that existed, but a prize for all the life that was yet to come.
So how do we know any of this actually happened? Well, geologists found the smoking gun right there in the rocks. If you look at rocks that are older than 2.4 billion years, you find minerals like uranite sitting in old riverbeds. This stuff literally falls apart if it's exposed to oxygen. But right around 2.4 billion years ago, it just disappears from the record. And instead, we start seeing these huge, massive layers of what is basically rust on the ocean floor, the famous banded iron formations. That was all that iron from those green oceans finally reacting with all the new oxygen in the water and sinking to the bottom. It's a geological fingerprint of a world changing forever.
The consequences were, well, they were apocalyptic. This event, which we call the Great Oxidation Event, was the planet's very first mass extinction, and it might have been the biggest one ever. It wiped out countless species that were poisoned by the very air. It completely rewrote the chemistry of our oceans and our atmosphere. It even created brand new types of minerals that had never existed before. Earth was being remade from the atoms up.
But out of that crisis, a new world was born. So let's take a look at the incredible legacy that the oxygen revolution left behind.
That toxic waste product now makes up 21% of the air we're all breathing right now. Every single breath you take is a direct link billions of years long, back to those tiny cyanobacteria that started it all.
So why was oxygen such a prize? This chart tells you everything you need to know. Using oxygen to get energy from food is like upgrading from a bicycle to a rocket ship. Oxygen is super reactive, and it lets cells get way more bang for their buck. The process unlocks a massive amount of energy compared to life without it. We're talking something like 16 times more efficient.
And this huge energy surplus, that's what paid for complexity. It's what allowed life to get bigger, to build specialized cells, to start moving around, hunting, and even thinking. Without the high-energy lifestyle that oxygen makes possible, there would be no animals, no complex plants, and there would be no us. Simple as that.
And the amount of oxygen in the air has continued to shape what's possible for life. There was a period called the Carboniferous when oxygen levels actually spiked even higher than today's 21%. And what was the result? Life got supersized. We're talking about insects like dragonflies with the wingspan of a hawk. Can you even imagine that?
So, we'll leave you with this. The story of oxygen shows us that life doesn't just adapt to a planet, it fundamentally changes it. A tiny microbe's waste product became the fuel for our entire world. It really makes you stop and wonder, what are the waste products of our own time, and how might they be shaping the world for the next billion years?